Right, ready. Okay, first bit is obviously just to understand the basics regarding trigonometry and what it actually does. So, if you look at the word trig, what does that focus on? Like, what is its purpose?
To find a missing side or missing angle.
Yes, so it's looking at angles and their sides in terms of measurement. So that's the one aspect. And the other aspect would be graphs in terms of sine, cos, and tan. So here, they're not looking so much at like sine rule, cos rule, that type of thing. Here they're looking more at the graphs, so sec, cosec, and cos. Okay, so we need to remember what sine, cos, and tan are in order to get sec, cosec, and cos. Okay, we've touched on it before, but let's revisit that. So let's start by defining what sine is, what cos is, and what tan is. Okay, so what is sine theta equal to?
O over h.
Over h, correct. Opposite over hypotenuse. What is cos?
A over O.
Correct. A would be the adjacent over the hypotenuse. No, over the hypotenuse, so not O. Yeah, so both sine and cos have the same denominator.
Adjacent over
Hypotenuse. And the last one is tan. Tan is
O over h. No, O over A.
correct, O over A. Right, so those are the basic relationships in terms of triangles and the actual angle. Okay, so now we're looking at the opposites of those things. So when looking at sine, you get cosec, and when you're looking at cos, you get sec. So the inverse of sine and cos are cosec and sec. So let's
the inverse of sine.
Yeah, so basically 1 over sine is equal to cosec. Cosec equals 1 over sine.
So the inverse of sine is cosec.
Yes, cosec theta. S-E-C. That's theta. Right, and what is the ratio? It'll be 1 over sine. And that'll be hypotenuse over opposites.
Pardon?
1 over sine, so cosec theta equals?
Cosec theta
equals 1 over sine theta. Okay.
No, because it's the inverse.
And what is its identity? Opposite, well, opposite is the opposite, so it'll be hypotenuse over opposite, because sine was opposite over hypotenuse, so that would be h over O. Okay, then the same thing, but with sec. That relates to cos. Okay, so inverse of cos is sec.
Just sec.
Yeah, no co in front. Yeah, so sec theta would be 1 over cos. 1 over cos theta. And that's the same as hypotenuse over adjacent. Okay, and the last one is tan. Inverse of tan is cot.
Just cot.
Yeah, COT, cot theta. What is cot theta? 1 over tan. And 1 over tan as an identity would be adjacent over opposite, the opposite of the tan. Okay, then you've also got other identities that we've seen before. This was covered in the first part when we looked at trig the first time. Do you remember what tan is in terms of sine and cos? Okay, so tan theta can also be written as sine theta over cos theta. Okay, they've given that as well. Cos over sine, okay, which is sine over cos, same thing. Okay, so next bit. You can call these identities. So an identity would be like something that is molded in a different shape. Okay, so you can use either or. It just depends on what you've got in the actual question. Right, so tan theta can also be written as sine theta divided by cos theta.
Okay, so tan
That one we've seen before.
theta can also be.
Yeah, tan theta is the same as sine theta divided by cos theta.
Sine theta over cos theta.
Yeah, numerator, denominator. Okay, so if that's tan, what will cot be?
Tan cot.
Cot will be the opposite. So cos theta over sine theta. Okay, then you've got a few others that we've seen before. Sine squared theta plus cos squared theta equals 1. Okay, that one you should know from when we first covered trig in the work program. Okay, so sine squared theta plus cos squared theta equals 1. Okay, that's an identity. So you could write either or. Sine squared plus cos squared equals 1. Then these are two new ones. Okay. Sec squared equals 1 plus tan squared theta. Okay, the other one is cosec squared. Cosec squared is the same as 1 plus cot squared theta. Okay, you got those two. Okay, I just want to give you a little, like a phrase that when I was studying this like at school, our teacher gave us a way to remember these things. Okay, so you've got these two, 1 plus tan and 1 plus cot. Okay, so if you look at the second one, 1 plus cot. Okay, a cot is something that a baby sleeps in, right? So we used to say 1, so the 1 with the cot is cozy. Okay, because cozy, cosec.
Oh, okay.
Okay, so that was what we used to remember that. So these things you need to study and remember. So we used to say the one with the cosec, the one with the cot is cozy. Okay, because cosec is co with the se. That was just something she gave us to help us study all of these things because there were a lot. So you can use that. And then the other one, again, just to give you something that you can remember. The other one is sec squared equals 1 plus tan. Okay, so with that one, we used to say the 1 with the tan is sexy. Okay, so that was what we used to remember.
This one?
Yeah, sec. So sec squared, the phrase was the 1 with the tan. So 1 plus tan, in other words, equals sec squared. So the 1 with the tan is sexy. Okay. So those are just like silly things that you remember from school that you don't forget. Like even now, I still know what sec squared, cosec squared is because of those phrases. Okay, obviously the other ones, those you need to obviously study. You'll get familiar with them when you do more exercises and more questions.
When do you use identities?
When you need to solve, or when you need to simplify, or when you need to prove that the left-hand side is the same as the right-hand side. Okay, there's three main applications. The first could be solving for x or cot, or not cot, theta. Solving for the angle.
Identities when?
Yeah,
First thing?
you could say solving.
Solving
for something, x or y, or solving for the angle. It could depend. Okay, so just solving is fine.
Angle or side?
Well, angle or you wouldn't have a side here unless you're asked to substitute. So it could be more the angle or a missing variable. So variable, angle or variable or unknown. The second one will be simplifying. Okay, so they give you a long expression and then you can simplify it. Okay, so simplify makes it simpler, easier. Okay, and the last one would be proofs. Okay, so left-hand side equals right-hand side. Those are proofs. So prove that this equals that. Okay, left-hand side equals right-hand side. Okay, now those would be the three main. I see you've got another bullet, so let's think about. You could maybe say graphs as well. That could also work. Sketching or drawing or yeah, okay. Alright, so those are the two new ones that you've seen. Okay, here. Sec squared equals 1 plus tan squared. Cosec squared equals 1 plus cot squared. But other ones that they need you to know, I see here is the sine. The sine Coco rules. We need to go find those. This was the a plus b, and the cos a plus b and tan a plus b. Okay, so let's just find the summary for it so we can write them down. And then this is what you would study. Okay, so yeah, we've got all of that. We've got that. Okay, here's it. Yeah, the compound angles and the double angles. Okay, so that we also need to study. See, these are compound angles, and then these are double angles. Okay, so we need both. So you can write a separate heading for these. They're still identities, they're still part of this, but the separate heading is that compound angles. Okay, so subheading, compound angles. We've actually seen these before when we looked at the trig earlier. We used the cos a minus b, a plus b, all of that. Okay, so the first grouping would be the compound angles. Okay, compound means something making up of something else. Okay, so a and b making up an equation. Okay, so with compound angles, there's a few that you need to know. You've got 2 cos, you've got 2 sine, you've got 2 tan, 2 different compound angles. Okay, so the first one, cos bracket a minus b, close brackets, equals cos a multiplied by cos b, so cos a, cos b, basically, cos a, and then cos b.
Just next to it.
Yeah, it's multiply. Okay, so cos a times cos b plus sine a sine b. That's what the rule says. Okay, that's an identity. Okay, so if you see cos a minus b, you could write it as cos a cos b plus sine a sine b. Okay, there's the first one. Right, the next one is cos brackets a plus b, close brackets. Okay, so now we're looking at bracket a plus b.
Okay, so what is it?
It's still the same, cos bracket a plus b instead of a minus b. Okay. Alright, so cos bracket a plus b equals cos a cos b minus, and then sine a sine b. Right, so that's another identity, okay, relating to compound angles. Okay, so a plus b or a minus b. Yeah, the signs are the opposites. Yeah, so when you have a bracket a minus b, then you've got the cos a cos b plus, and you've got the, if you've got the a plus b, then you've got the cos a cos b minus. Okay, so the signs swap over. Okay, so that's sine. Let's look at cos now. No, that's cos. Let's look at sine now. Okay, so number 3, sine a minus b. Okay, that one is equal to sine a cos b. So sine a times cos b minus cos a times sine b. Okay, there's the one. The second one.
So it's minus and a minus.
Yeah.
They're the same now.
Sine stays the same. The sine, with sine, the sine stays the same. Okay, number 4.
Okay.
Sine. Okay, sine bracket a plus b. Exactly the same as the first one, except the sign is plus instead of minus. So sine a plus b will be equal to sine a cos b plus cos a sine b. Okay, good. And then we've got two tan ones. These are compound angles. Okay, so tan bracket a plus b. Okay, here you've got a numerator and a denominator. Okay, so the numerator is tan a plus tan b. That's the numerator. Okay, the denominator, so all of that is all over. So tan a plus tan b all over. Denominator is 1 minus tan a times tan b. So tan a tan b. That's it. Okay. Okay, and the last one for compound angles is tan bracket a minus b. So now instead of plus, it's minus. So tan bracket a minus b equals, same thing again, numerator, denominator. It's exactly the same as the top one, except swap the signs. So the numerator is tan a minus tan b. The denominator is 1 plus tan a tan b. Okay, so just switch the signs. Okay, perfect. So you've got all the compound angles, so now that covers that bit. Then we still need the double angles. Okay, then we've got all the identities. Okay.
So, what are compound angles? What does that mean?
Compound angles are two angles where there's a special relationship. They're added or subtracted. Okay, so A is one angle, B is another angle. There's two angles. That's why you've got A and B here. Before we just had theta, one angle. Here we've got two.
Okay.
Right, then the last bit of identities, separate heading, still part of identities. These are just rules that you need to learn and study and then apply. Double angles. Okay, so double angle will have one angle, but it will be doubled. Okay, twice the size.
Okay, so this is one angle.
Just say double one angle.
One angle.
Doubled. Okay, these you've seen before actually, so some of them will look familiar. Okay, the first one.
Just say. Okay.
Okay, the first one is sine 2 theta. Okay, so sine and then 2 theta. Okay, so notice it's a double angle. You've got 2 theta. So if theta was 30, then you would have sine 60. Okay, because sine 60 is 2 times 30. Does that make sense? Okay. Right, so what is sine 2 theta as an identity? Well, sine 2 theta can also equal 2 sine theta cos theta. Okay, all multiply. So 2 times sine theta times cos theta. Okay, that's what it's equal to. So you could replace 2 sine theta.
We have to know all of these off by heart.
Yeah.
So.
Okay, it just depends on when you have to apply it. So we'll look at application just now. This is just what they're talking about here. See, sec, cos, then here's the compound, there's the double. Okay, so yeah, with Trig, you kind of have like they call it a crib sheet. So we used to have a crib sheet where we studied all of that stuff. And then when you get to the exam, we used to just jot it down and then we had it. So it's like having your notes with you. We just wrote it down on the paper, the question paper, and then you've got everything. Then you just reference it. Some stuff you don't write down because you know that. Some stuff you do, like these are the more complicated ones. These you probably write down. Okay, just so you've got them. Whether you use them or not, at least you have them. Okay. Remember, this is paper 2. So you're not going to have to study all of this for paper 1. Paper 1 is paper 1. Paper 2 is paper 2. Okay, so it kind of helps you as well because they've split it. So paper 1, you study all the other stuff. Paper 2, you study all of this stuff. Okay, so it does help a little bit. They do understand that it's a lot. Okay. All right, so you've got the first double angle. Now we're looking at cos 2 theta. Cos 2 theta.
This is the second one.
Yes, cos 2 theta. So in other words, double angle for cos. Okay, so cos 2 theta, there are 3 options. Okay, you can see here. Option 1, option 2, option 3. All of them could apply depending what you've got. Okay, so I don't know how you want to write that. Do you want to maybe write equals to this, equals to that, equals to that?
Can we not just learn one, or do we have to know?
You have to know all 3. Yeah. Okay, because it depends. Okay, so the first one, cos squared theta.
Cos squared theta.
Minus sine squared theta. That's the first one for the double angle for cos. Okay. The next one, still double angle for cos, so cos 2 theta equals 2 cos squared theta minus 1. 2 cos squared theta minus 1. And the last one is 1 minus 2 sine squared theta. Yeah, so cos has 3 possible identities. 1 minus 2 sine squared theta.
So those are all 3, eh?
Those are all 3. Okay, then the last one is just tan double angle. Okay, and then we're done. Maybe we can go look at the notes in the work program. Okay. Right, so the last bit is a double angle for tan. Okay, you've got double angle for sine, you've got double angle for cos, double angle for tan is tan 2 theta.
Wait, what is this?
This is number 3, tan 2 theta, so double angle for tan. Tan 2 theta is equal to, here you've got a numerator and a denominator. Okay, so numerator is 2 tan theta, that's the numerator. 2 times tan theta. And all over, so divide by, denominator is 1 minus tan squared theta. 1 minus tan squared theta. Okay, and that's everything that you need for trig identities or simplifying or solving or whatever the question is going to focus on. Okay, that's all the basic trig stuff that we use. Okay. Alright, so let's go and have a look at what else we need to look at. So now we've covered that, we've covered that. Expressions of sine and cos that we've looked at, that was double angles. Okay, then we looked at sec, cosec, and cot, that's fine. And then they've given you graphs. What do they say here about the graphs? Do you have to draw these other graphs? Maybe. Let's see. Notice that your calculator does not have sec. Oh, okay. That's just a note about the calculator. Okay, so let's put a note for it because this is for the solving. So you can put a heading. When solving for sec, cosec, and cot, if you look at your scientific calculator, it's a note.
Okay.
Yeah. When looking at your calculator, do you see sec, cosec, and cot? No. Okay, the reason why the calculator doesn't have it is because they're inverse functions of something else. Okay, so the only way you can insert sec into the calculator is to put 1 divided by cos. That's why you needed those identities. Okay, so that's just a note. When solving for angles using the calculator, let's write them all down. Okay. So I'm just going to give you the 3 again. Yeah. So when solving for angles using the calculator, cosec, comma, sec, and cot. So the three that we saw today, cosec, sec, and cot must be converted to cos, sine, and tan, obviously. Okay, or sine, cos, and tan rather. Because cosec is sine, sec is cos.
Must be converted to?
Sine, cos, and tan. Right, so that's what they've given you there. Let's do one to practice. Let's see if you can work it out. Okay, so e.g. example. Solve for cosec 35 degrees. Okay, so what would cosec 35 degrees be? The calculator can work it out for us, but we need to get it in the right format. So what is cosec 35? How can cosec 35 be written as in terms of sine? There we had it. Okay, what is cosec? Other page, the basic ones. Yeah, there. What is cosec? Exactly. Right, so you could write down cosec 35 degrees equals 1 over sine 35. And can I solve that on the calculator? Yes. So now grab the calculator and do that calculation. 1 divided by sine 35 equals what? You should get the same answers they've got here. One point?
7.
Perfect. 1.743. Good. Okay, just another note here. I see they're giving another example using radians. Okay, remember we had a radian? A radian was that whole pi story. I don't know if you can remember that. So you can just put a note. Radians can be substituted in as well. Okay, so you can substitute degrees or you can substitute radians. It doesn't matter. It's just a measure. Okay, your application is the same. Convert cosec to sine and then calculate. Okay. You can put a note. Radians can also be used. Okay, the radians would have been the stuff that we've covered previously. Okay, we had 1 radian. Remember that relationship between radians and degrees? There was a formula for it. I don't remember what it was offhand. Okay, if we need it, we'll go back and we'll look at it. Okay. Alright, perfect. Then you've just got a note here about trig functions and graphs. So they've talked about the inverse of sine. Okay, obviously the inverse of sine is arc sine, so we need to put a note about this. This is graphs, okay, the sketching.
New heading.
Yeah, you can put a new heading. You can just say inverse, say inverse trig functions and then graphs. Because the graphs relates to these inverse functions.
Okay, just write graphs.
Okay, then brackets or arrow, inverse trig functions. Okay, I see that they've only given you 2 here. Well, 1 actually, and then they've given you 2 sketches, 2 graphs. They've drawn 2. But it would be very difficult to actually draw a radian graph, but it's possible. It'll look similar to the one here that they've given you in the work program. You'd have to do a conversion though. You'd have to convert one to another and then draw it. So we'll have to see if you actually need to sketch these graphs later. Maybe let's just quickly check the assignment just to see. Okay, so the next assignment that's coming up is 5. Do you need to sketch here? Find, use, solve, express, solve. No, okay, so it's all application. Right, yeah, I've never had to draw these graphs. So if you had to, that would have been like tough. Okay, it's possible. I mean, you can sketch it. It's quite easy to. You just look at X's and Y's, but it would take quite a long time. Okay, so what we need here is just a note about the inverse. So they've given you a statement here. The inverse of sine x is written as arc sine. Okay, arc sine is sine to the minus 1x. Okay, that's the inverse. So when sketching graphs, you could identify the graphs as being an inverse if you've got the minus 1. Okay, minus 1 means what? 1 over sine. So it's the same thing, really. But let's just make a note for it. The special word is arc sine. Okay, so arc sine, A-R-C-S-I-N, arc sine.
Is this number 1?
No, it's just a heading. It's just a discussion point underneath this heading. Okay, so arc sine, A-R-C-S-I-N, arc sine. Arc. Arc doesn't have an H at the end, yeah. It's just arc, A-R-C-S-I-N, arc sine. Yeah, so obviously arc is in like building, an arc. That's correct. Okay, but here they've left out the H. Okay, so arc sine theta represents the inverse of sine. That's what it represents. So if we see the notation, the only reason why I'm giving you this note is because sometimes they can use arc sine instead of sine minus 1. Okay, it's just the inverse, so it relates to the inverse. This is notation mainly. Represents the inverse of sine theta. Okay, sine theta can also be written as, or arc sine theta can also be written as 1 over sine. Okay, you can just say 1 over sine is the inverse. 1 divided by sine x. Right, they've drawn graphs here. If you want to, you can just like reference this. Let's just say see page. What page numbers? The 63 and 64 in the work program. See, here's arc sine, here's arc cos, here's arc tan. Okay, the word arc is just referring to the inverse. Okay, so arc anything is inverse of what it is. Okay, that's the key to take away. Okay, so see, arc sine, arc cos, arc tan. Okay. Alright, so here they've said you should learn these identities. Okay, so which ones do we have? This one you've got. Let's check if we've covered all of them. Sine squared, cos squared you've got. The one with the tan you've got. The one with the cot you've got. Sine A and B you've got. A minus B you've got. Sine 2A you've got. That you've got, that you've got, that you've got. Okay. Sine squared A. This one you don't have. I see they've given you a few more here. Let's write them down. Okay, we're going to have to add them. Maybe start on a new page. Heading, additional trig identities. Okay, the work program has given you more even. Wow. Okay, you've got more to study. Okay, we've already looked at most of them. I'm just giving you the ones that we haven't looked at yet. Okay, so this one we haven't looked at. Okay, more identities are. The first one, sine squared theta. Okay, so sine squared theta is the same as equals a half, big brackets, 1 minus cos 2a, 2 theta, sorry, 2 theta. We're using theta. Okay, there's the first one. Okay, so we've got one. Then there's another one. Cos squared theta. So now you've got sine squared. Now we need cos squared. Cos squared theta is the same as equals a half bracket 1 plus cos 2a. Okay, so it's very similar to the top one. Instead of minus, it's plus. Perfect. Okay, so those are two that we haven't looked at yet that they've given you here. Okay, wow, they've even looked at half angles. That's very strange. Okay, I don't think these half angle ones are important. See, sine squared half angle. I mean, a half angle would be a big angle divided by 2. Okay, would be that big angle. So that big angle is with a half angle.
Maybe when we're going through the past papers, you'll see.
We can check, yeah. So that looks very weird. Yeah. Sine 3a cos 2a. Okay, that one you can use because if you've got 3 times the angle, that you can apply. Okay, so these two are useful. Okay, so number 3. What happens if I have 3a or 3 theta? So sine 3 theta. 3 theta. So this is a triple angle. Okay, sine 3 theta is the same as equals 3 sine theta minus 4 sine to the power 3 theta. Yeah, minus 4 sine 3, yeah, sine cubed theta. Perfect. Okay. Right, so that's what for sine. Then let's look at cos, triple angle. Okay, so cos triple angle, so cos 3 theta is the same as 4 cos to the power 3 theta minus 3 cos theta. That's the identity. Okay. This one we've looked at. Tan A plus B we looked at. Tan A minus B we looked at. The one with the tan we looked at. This is looking at sine plus sine. 2 sines. Okay, even with these we might or might not need. Sure, that's a lot of studying if you need to learn these. Have a look at these. Sine P plus sine Q equals 2 sine P plus Q over 2 cos P minus Q over 2. Okay, that's complicated, yeah. Okay, so maybe let's just circle those in the actual work program. I don't think these are important because I've never had to use them specifically. No, those 4, yeah. That one you will because that's what we've got already. Okay, it's just those 4. This one you've already got. Okay, the sine plus rule. Okay, that's fine. So it's just those. I don't know if you need these. We'll have to check. Okay, because this is P plus Q. Okay, because you've got an angle where you've got P plus Q divided by 2. Right, so maybe just put a note there. Page 64. Sine P plus sine Q.
Okay.
Yeah, these ones, sure, no. Don't think you need them, but we'll have to see. We'll have to check. Okay, I don't think so, but we never know. they could test it. Okay, page 64. It's only for those additional 4. Okay. Right, that covers that bit. Let's see, what do we have here? Okay, this is still trig, but separate. It's a different application. This is for the solving for, simplifying, eliminating. Okay, so still trig, and that's the last part. Okay, so 4 more pages. Okay, so I think new page, new heading. Okay, so all of this that's coming up now is the solving. What we looked at earlier was the simplifying, okay, the identities, the substitution. Okay, so if you want to put a heading here, you can say calculations, trig calculations. See, solve for x, find the value of, those type of things. Okay, that's what we're looking at here. Okay, so the first one, solving for, or maybe to say solving without using a calculator. Okay, so we know that cos 15 is plug in to the calculator and get an answer. Okay, but sometimes they require you to show it, but without using a calculator.
Okay, solving without.
Yeah, so solving without a calculator. Okay, what do you do when you don't have a calculator? You would use special angles. Okay, so that's the key, special angles, using special angles. Right, so if you don't have a calculator, or if they ask you solve without the use of a calculator, then you have to use special angles. Okay, and the special angles would be 45 degrees, 30 degrees. Okay, those are special angles.
$45 and
30 degrees, yeah, those are special angles. Okay, so example. Find cos 15. Obviously without the use of a calculator. Okay, that will be part of the instructions. Find cos 15. Okay, so do you agree, on my calculator I can say cos 15 and it'll give me an answer. Okay, that's the easy way of doing it, but sometimes they require you to simplify or to solve without the use of a calculator. Okay, so what must we do here? We need special angles. I don't have a special angle for 15, but I've got a special angle for cos 45 and sine 30. Okay, those angles, 45 and 30, are special angles. Okay, so can I rewrite 15 in relation to 45 and 30? Yes. Okay, so on the next line, cos 15 is the same as cos, open brackets, 45 minus 30, close brackets. Right, so I've used special angles to get rid of the 15.
Equals cos what?
45 minus 30, close brackets. Okay, so do you see that? Cos 15 is exactly the same as 45 minus 30. Right, do I have an identity? Yes, I do. Okay, so which one am I going to use here? Let's go back to your rules, and I'll show you how to apply it. Okay, let's find a compound angle rule.
Why is it compound over this 2?
Because there's 45 and there's 30. That's your A and your B, basically. Okay, so let's look at this. Go to your notes. You've got the summaries. Where's your compound angles? There's your compound angles. Okay, which one do I have here? A minus B. Do you agree? So where's A minus B? Where's cos A minus B? There's it. Cos A minus B. So I'm going to use that for this one. Okay, so cos bracket 45 minus 30 is the same as, Okay, so here, cos A minus B is equal to cos A times cos B. So what is cos A going to be in your question? Cos 45, exactly.
Okay, so I'm just write it, so it's cos A minus B equals cos A times cos B plus sin A times sin A.
Correct. Now just apply it.
Okay, so it would be
So cos bracket 45 minus 30 equals what?
Cos 45 times cos 30 plus sin A times sin B.
Yes, so sine A would be sine 45, sine B would be sine 30. Okay, good. And now those are all special angles. Cos 45 is a special angle, cos 30 is a special angle. Sine 45 is a special angle, sine 30 is a special angle. Okay, so now I can substitute what those things are. Okay, so this you can use your calculator actually. So on your calculator, type in cos 45. It should give you the special angle of 1 over root 2, does it?
Cos 45
Yeah. Does the calculator give you 1 over root 2?
gives me root 2 over 2.
Root 2 over 2. Okay, so root 2 over 2 is the same as 1 over root 2. See, let me show you that. Okay, so the calculator can actually help you with special angles. So when you typed in cos 45, the calculator gave you root 2 over 2. Do you agree? Okay, here in the textbook, they're going with cos 45 as 1 over root 2. Okay, 1 over root 2 is the same as root 2 over 2. I've just rationalized the denominator. So if I multiply this by root 2 and I multiply this by root 2, okay, what is root 2 times root 2? 2. What is 1 times root 2? Root 2. So see, root 2 over 2 is the same as 1 over root 2. Okay, so you can actually use your calculator to do special angles. Writing down root 2 over 2 would be fine. It shouldn't be a problem. Okay, so you could write that down if you wanted to, or you could have written that down. It's the same thing. Okay, so I would rather use the calculator here than rather having to study the special angles, because special angles require this. See, they require that. Okay, 30 degrees, 60 degrees. This is the hypotenuse. Okay, well that's the hypotenuse. Then I'm looking at that would be the opposite. That would be the adjacent. Okay, so sine 30 would be opposite over adjacent. Okay, and then you would do the same thing. 45 degrees, 45 degrees. Hypotenuse, and then opposite and adjacent, and then the root. So this you can study. I think they might even have given you these special angle triangles in the textbook. I remember we mentioned something along those lines. Okay, but you can study them, or you can just use the calculator. I think using the calculator is easier, but then you just need to remember that rationalizing the denominator. Okay, so let's write that down. Equals. Okay, so what is cos 45? Just write it down. What is cos 45 as it is on your calculator? Root 2 over 2. Good. So, next line equals. Where you see cos 45, put root 2 over 2. Okay, let's do the same thing for cos 30. What is cos 30 as a special angle?
Derivative.
See, that one's perfect. See, that is the special angle. See, the calculator can help you with that. Okay, root 3 over 2 is the perfect special angle. Okay, and then plus, let's substitute sine 45. What is sine 45 as a special angle?
Root 2 over 2.
Good, root 2 over 2. They've just used 1 over root 2, but it's the same thing. You've just rationalized the denominator. Okay, and then the last one is sine 30. Sine 30 is a nice, easy special angle. Good, 1 over 2. Okay, so now I need to multiply because you've got an addition there, right? Okay, so does the first two terms, are you multiplying those two? Yes. Okay, so root 2 times root 3, what is root 2 times root 3? I think it's root 6. Yeah, it is. Root 6. Okay, so root 6 over 2. That's if you multiply. Actually over 4. 2 times 2 is 4. Yeah, be careful, it's multiply. Okay, and then you've got the other one. What's the other one? Root 2 over root 2. Okay, that's just root 2, so it's root 2 over 4. Okay, multiply. Okay, 2 times 2 is 4. Root 2 times 1 is root 2. Do you see that?
So what's the answer?
Plus root 2 over 4. And that's the same as what they've got there. Okay, see? Except they've just used 1, 4 instead of 2. Root 6 plus root 2 over 4. Okay, there you go. Right, so that's what you would do if you were asked to use special angles, no calculator. But you can use the calculator to help you with the special angles. Right, that covers that section. Okay, earlier we spoke about proving identities. I see that given you a note about that. You've written it before. Remember you wrote down those applications. When will you apply identities? Okay, so I think that's fine. Here at the bottom of page 65, they say, proving identities. You will be given a left-hand side and you have to fiddle with it until it equals the other side. Okay, left-hand side equals right-hand side. Okay, that's an identity. That's something that you could be asked to do. Okay, here we've got eliminating a variable between two equations. Let's see, is this application? Yes, okay, so if you've got tan, okay, yes, that's just a substitution to solve for. Okay, that's fine, that's normal algebra. Okay, this is an equation. This is something that we need to look at. Okay, so next bit, still trig calculation, same heading, separate one. This is number 2 now.
Okay.
Okay, so number 2 is solving equations. Second application. Solving equations. Right, let's use an example. Let's do this one because it's got a substitution as well, which is good. Okay, so solving equations, you can just put a note if you want to. Use identities to simplify the equation. That's important. Okay, because when you've got lots of big things like sec and cos and tan and all of that, you need to then simplify it. Okay, so that's
identities to simplify
the equation. Okay. Right, so here's the example. E.g., sec squared theta.
E.g., sec.
Yeah, sec squared theta equals 3 minus tan theta. Okay, they've given you a domain here as well. Okay, so theta is greater than or equal to 0 degrees. Okay, so theta is bigger than 0 degrees. Okay, 0 degrees, just put a little degree sign. Okay, and theta is less than or equal to 360 degrees. Okay, there's your first quadrant stuff. Okay, remember we looked at that quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we looked at where is the sine, cos, tan positive. Remember that? Okay, so the same thing would apply here as well. But we need to first do what? Can you work with sec and tan? Definitely not. So what must you do? Simplify using identities. Okay, so which one am I going to simplify? The sec or the tan?
So can't work with sec and tan,
so simplify using identities.
Okay.
Okay, so is it possible to simplify sec?
Yeah.
Sec squared? What is sec squared? 100%. So let's write that down. 1 plus tan squared
equals okay, so now I can say
yeah, so if you're substituting 1 plus tan in theta equals 3 minus tan theta. Okay, that's good. Okay, now get everything to the one side. Okay, so because this is an equation, equations need to equal 0. Okay, so tan squared theta, or 1 minus 3, that's fine, yeah, that's good. You've taken the 3 across. Okay, plus tan squared theta. Okay, if the minus tan on the right comes to the left, what happens? It becomes plus, good. Equals 0. Okay, solve, simplify.
minus 3 is minus 2.
Yeah. Okay, just rewrite it better. So write down the tan squared theta first. Tan squared theta plus tan theta, and then write down minus 2 equals 0. Okay, does that look similar to something that you've seen before?
Trinomial.
Perfect. Okay, so let me give you a trinomial. X squared minus x minus 2. Okay, can you factorize that?
Yeah.
This should have been a plus, not a minus. Okay, just factorize that.
Minus 1 minus 1 and minus 1.
No, minus 1 and minus 1. If I multiply, we get plus 1. Okay, so remember.
So minus 1 and 2. No, 1 and minus 2.
Well, 1 and 2 is correct, but now I just need to see where the sign is going to go. Yeah, so where's the
minus
sign?
1 plus 2. No, plus
Minus 1 plus 2 is correct. So. Okay, so see, you could factorize this. Do you agree? X squared plus x minus 2 is that. But now, what do I have here instead of x? I've got tan. See, this is the same as tan squared x, or theta, plus tan theta minus 2. Okay, so what am I going to write down? See, that is your tan theta. Okay, so this would be tan theta minus 1, tan theta minus plus 2. Okay, do you see that? Okay, so I'm using something basic because you know how to factorize that. But now this might look confusing because you've got tan squared instead of x squared. X squared plus x minus 2 can be easily factorized into that trinomial. Right, so I'm just using this to apply to trig. Okay. Right, and then you should be able to get it. Yeah, so now you've got tan a minus 1 and tan theta minus 1, tan theta plus 2. Good. Okay, we still need one more step. We just need to get the angles. Okay, so the last step is to solve. So now, if you've got an equation like that, do you agree? Maybe just to write this down. Okay, here I had x minus 1. So that means x must equal 1 or x must equal minus 2. Do you agree? Okay, so now I'm going to have that, but for this one. So here I'll have tan theta equals 1 or tan theta equals minus 2. Does that make sense? Okay, so can we work that out now? Yes, we just need to use the calculator. Okay, so you did the factorizing.
Tan theta.
Yeah, so for this bracket, tan theta equals 1 or tan theta equals minus 2. Okay, that's why we've got that. Does it make sense? Okay, now is it possible to work out the angle theta? Yes. What do I do on the calculator? Shift second function, right? So shift second function tan 1 equals 45. Okay, so theta equals 45 degrees for that first one. Or what else could it equal? Let's check the other one. Okay, so shift second function minus 2, well, tan minus 2 is what? 116, comma 6.
63.
Tan minus 1, oh, minus 2, yeah, because that's the negative, but yeah, we'll apply the domain just now. Yeah, so you can write that answer down, that answer's fine. Okay. Right, do you remember what the period is for tan?
Is this degrees?
Yes, because it's the angle. Remember, shift gives you the angle. Second function tan. Okay. Do you remember what the period is for tan? Period for tan is 180. Period for sine and cos is 360. Remember that? Remember when we drew those graphs? Every 360 degrees we drew another graph. Okay, for sine and for cos. Remember that? Period for tan is 180. Okay, because every 180 will have that graph, that little line, that squiggle. Okay, is that okay? Right, so that's revision relating to tan. Okay, so now I'm looking at a domain of what? Greater than 0 but less than 360. That was the question's domain. Okay, so I'm only looking at the degrees from 0 to 360. That's all. Okay, so let's look at our answers. Is 45 degrees meeting the domain for this question? Yes or no?
Yeah.
Yes, it is. Okay, so if it's meeting the domain, is that a possible answer? Yes. So final answer, 45 is an answer. Theta equals 45. Or, now we need to check. Okay, so if the period is 45, if I add 180 to 45, what do I get? On the calculator, 145 plus 45 plus 180 is how much?
225.
Good. Is 225 part of the domain? Yes, so 225 is also an answer. Okay, so now you've got two answers. You've got 45 and you've got 225. Now we need to check the other one. Okay. So you see our meets domain, theta equals 45 or theta equals 225. Just carry on with the final answer. Just keep writing there in blue. Yeah. So now you've got another answer. There's still two more here, so I hope you have enough space for two more. Okay. 225, that's what we got. Okay, when we added 180 to 45, we got 225. Is 225 part of the domain? Yes. Perfect. Okay, 225. Now we need to check the other one. Is minus 63, 4 part of the domain? No. Minus 63 degrees is less than 0. We cannot have that. But now I need to check the period. So I need to add 180 to that answer. Does that make sense? Okay. So take that minus 63, 4. Add 180 to it. And what do you get? $116, right? 6. Is that a possible answer?
Yeah.
Definitely. Okay, so that is the possible answer. If I add another 1/8 to that, am I still in the domain?
Yeah.
What do I get? 296. Okay, is 296,6 part of the domain? Yes, because 296 is less than 360. So I've got 4 answers. Okay, and those are the 4 answers. Right. And that's how you do the solving. Okay, it's quite a long process because you always need to check the domain. Okay, there's one more thing that we need to look at here. Do you need a quick break?
Okay.
Are you sure? Okay. All right, there's one last thing here that we just need to write down from the work program, and then we've covered this section. Okay, we won't start with the new section. We'll start with that next time. Okay. Actually, we can do the assignment because, yeah. Okay, because now we've completed P2, trig. Okay, P2 differentiation is the next section. Alright, so we can actually look at the assignment on Friday then, for maths, assignment 5. Maths, you haven't got any assignments back. Yeah, only the counting they sent back. Okay, then we've got those 3 sections left and then we're done. Okay, then we can start looking at past papers. Okay, so if you're okay to finish that last page and a half, we can do it quickly now then. Okay, then we've finished that section. Okay, so last bit. You've done well today, lots of notes. So last bit, last page and a bit, and then we're done. Okay. Right, heading for this, R cos bracket x minus alpha. Okay, it's a special case. Yeah, this is a special case. So this is looked at in isolation to what we've looked at before. Okay, it's its own little section. Okay, so that's the heading. Alpha. Alpha is that fancy symbol. It's a Greek letter for alpha. Yeah, alpha. It's just like it's almost like a infinity sign, but not complete. Okay, good. Right, you can circle this or just put a note for it. You can say special case or special notation, either or. Let's say special case because you'll see why. Yeah, that's just an alpha sign. It's just like, you know, theta. Theta is a Greek letter. Alpha is a Greek letter. You get lots of different Greek letters. Okay, because the mathematics that we use today come from the Greeks. Okay, Pythagoras and all of that stuff. Okay. All right. So just a heading or a note about this section. Special case / notation. Okay, it's mainly notation actually. Okay, so what do we mean when we have that big R in front of a cos? Okay, so do you agree this is a trig function? But because you've got R in front of it, this has a specific notation or format or special case that we need to represent. So what does this R in front of the cos represent? That's what we need to look at. Okay, so you can say when we have R, this is an alternative way of writing small a cos x. Yeah, so this is what we're actually looking at in terms of format. Okay, so when you have that big R, it's representing small a. Yeah, writing small a cos x plus minus b sine x. Okay, so small b sine x. Yeah, and that's it. Okay, so when you see something like that, R cos bracket x plus alpha, it's telling you that you've got an option where you've got a plus cos x sine x and you've got a cos x minus sine x. Okay, you've got 2 options. So there's two possibilities when looking at this. Okay, the R gives you that note. They also talk about the size of the angle. So to keep R positive and alpha acute, we select the formula corresponding with the positive and negative signs. This technique is the same whichever formula we use. Okay, so just a note, you can write that down. Keeping R positive and alpha acute. Okay, what is an acute angle? Do you remember your basics? Acute means less than 90. Good.
Keeping R positive.
Yeah, keeping R positive and alpha acute. Okay, acute means less than 90. Okay, you don't want alpha to be more than 90. That's problematic. Okay, because then you've got a separate rule working altogether. Okay. We select the formula with the corresponding signs. That's all. Okay, it's as simple as that. Okay, so if it's plus, it's going to be plus. If it's minus, it's going to be minus. Okay, so let's just show that as an example. The solution is here, so I'm not going to go into all of the detail because we've already looked at that before when we were solving for the angles. Okay, let's just apply the R. Okay, so e.g., how do we apply this R cos x alpha? Okay, so example, solve the equation 12 sine x.
Sorry. 12 sine x.
Minus 5 cos x equals 6. Okay, so that's the question. They give you a domain. They have to give you a domain because remember you're looking at trig. Okay, so domain for this one, x is greater than 0 and less than 360.
X is
Greater than 0 and less than 360. Okay, 360 degrees, 0 degrees. Right, so that's the domain, that's the question. Right, so looking at this, what do you have? You've got 12 sine x minus 5 cos x equals 6. Do you agree? Okay, so what did the rule say earlier? When I have r cos bracket x minus alpha, okay, I can rewrite that according to one of those rules, according to one of, where did you write it down? There, according to that. Okay, using the same sign. So what sign do we have in the question? Positive or negative?
positive.
Negative. It's minus. Minus. It's minus 5.
Yeah, but sine is positive.
Okay, well, sine is positive, but what's the sign in the middle? That's the key.
Minus.
It's negative. Yeah, so you've got sine minus cos. Okay, so the minus tells you that you need to use what? The equation with what sign? See, it's plus minus, a minus, exactly. Okay, so I can rewrite on the next line, this question, 12 sine x minus 5 cos x equals 6, can be written as...
Sorry.
Let's see, where is the substitution? Okay, that's the cos and the sine. That's what they've used the substitution, the coefficients. Okay, here they've used. Okay, so r sine bracket. So you can write that down. R sine bracket x minus alpha close brackets.
You're going too fast.
Okay, sorry. R sine brackets x minus alpha close brackets. Okay, so basically the top bits. Okay, so that equals r sine x cos alpha equals sine x cos alpha minus r cos x sine alpha. Okay, so there's the rule. That's what they've said we needed to do. Okay, cos x sine alpha. Okay, good. Right, so now, if that is the same as 12 sine x minus 5 cos x, we can then solve. Okay, because you were given what? 12 sine x minus 5 cos x. Okay, so what do I have here? I've got r sine x cos x minus r cos x sine x. Okay, so here they've used coefficients of sine x and cos x to solve for r. Okay, and then they've got an r as being positive or r as being negative. Okay, so looking at what you've been given, they said find the maximum value of 12 sine x minus 5 cos x and the smallest positive value of x for which it occurs. That was the instructions, and then they solved for it using that. Okay, it's 12 sine 12 sine x minus 5 cos x equals 13 sine x brackets x minus 22 comma 6. The 22 comma 6 came from there, substituting that in. Okay, the r cos x, the r cos alpha equals 12, and the r sine x equals 5. Okay, so to relate this to that, let's circle the 12 in a color. Okay, what does that relate to? Here, the r. Okay, because here you've got sine x, there you've got sine x. So that relates to the r cos x. Okay, and then just underline the cos x, or circle it as well, cos x. Okay, and then different color. Okay, so looking at this, you've got minus 5 cos x. Okay, here you've got r cos x sine x. So circle this r and that sine x with that minus 5. Okay, well, 5. Okay, and that's what they've used. So they've used the coefficients of those x's and y's in order to solve for the answer. Okay, that's tricky because you need to then substitute and then you need to solve. You can see it's quite a long process. Okay, do you have to do it this way? No, because you have those compound angles and double angles that you can use to substitute in. Okay, so this is just for notation relating to r if we need to substitute and solve using those coefficients. Okay, so last point you can add there at the bottom, you just asterisk it. Okay, r is specific notation in order to solve for angles.
Was alright?
Yeah, r is specific notation that's used to solve for specific angles. You can just apply the normal trig. Okay, I think this confuses it a little bit. It makes it actually longer than what it should be. For specific angles. Yeah, solving for specific angles. Okay. Alright, so if we do need to use r, and they say use r, then we'll use it. But if not, there's no need to use it. Okay, you've got the rules that can be substituted in. Okay, this makes it a lot longer because you're solving for coefficients before you're solving for the angles. Okay. Alright, so that covers that section. Bring the maths on Friday because we'll look at the assignments.
Okay.